Right, now let's learn how to work with a %f format specification. We're going to use %f when we want to print out data types float and double. Right. We'll see that its default behavior is that when the number is positive, no plus sign is displayed, but when the number is negative, a minus sign is displayed. And then the default is to always display 6 digits after the decimal point. Right. So let's go ahead and take a look at some examples with %f. Right. We've got some code right here where I've declared a variable named value1 and stored the number 1.23 in there. Right. We've got some code to print out 2 blank lines in a tab to make the output a little more readable. Let me do a build and run. Right. So what we're doing here with printf is I want to print out what's stored in value1. So here's my text then labeling my output. Right. We always want to put labels on so we know what the output is. Then here is my format specifier. Remember, it starts with a % sign. And for a floating point type, right, for a float or double, we use the F. And that's kind of easy to remember. Floating point type, use the F. Right, it's going to show the number in base 10. It will always show in base 10. You can't change the base. Right. And then remember the variable name or the expression that I have out here, the value of this expression is substituted in for the %f. This %f is a placeholder here in the string. Right. And so we can see then that the output is 1.230000. So we said then the default behavior of using %f is that when the number is positive, there's no leading plus sign, right? And that we always get 6 decimal places. So you can see we got the 6 decimal places there, the default. Right. Let's just go ahead and change this to negative 1.23 so we can see that it does display the negative sign when the number is negative. Right. And there is the negative sign as well. Right. All right. And just like we had in the previous example with integers, if we have multiple floating point values we want to display, so let's make some other variables here. Float value 2 equals 9.99. Let's just put an extra decimal place there. All right, so to see value 1, we have that. Right, to see value 2, right, we need another %f. We need to add that to the list. Right, value 2. Remember, there's a one-to-one correspondence. There's an ordered correspondence. There's a one-to-one correspondence between if we have 2 specifiers here, we need to have 2 expressions in this list to the right of our control or format string. And whatever the first expression is will be substituted into the first specifier. The second expression, that value will be substituted into the second specifier. Right. So let's just do a build and run to see that behavior. Right. And now we can see, right, we value 1, it's substituted in minus 1.23, 6 decimal places. Value 2, 9.999, 6 decimal places. Right. And once again, to illustrate the order correspondence, if I were to change this from value 2 and this to value 1, the fact that this label says value 1 doesn't guarantee that that's what is printed out. Remember, what will be substituted in here is the value of this expression. Right, so we're going to see the value 2 will be substituted in there. Yes, so value 2 is substituted in here, value 1 is substituted in there. Like I said, pay attention to your list, right? When you type things out, it's not a common error that you'll type them out in the wrong order, but always check if your output doesn't look right, check your printf to make sure you have things in the right order. Right, and you're using the right specifiers. All right, so let's just go back to our example then of one value here. Right, and let's illustrate that if this is a double, that this %f will work as well. So I'm changing the data type of value 1 to double. Got rid of value 2 from our example. We're just going to print out the 1. Let me compile. Right, let me bring up my log of messages. Let's build and run. And you can see as well, it works for the double. Right, 6 decimal places leading, negative sign when it's negative. If it were positive, we would not get a leading plus sign. And let's see what happens when we have a lot of decimal places. 2, 3, 4, 5, 6, 7, 8, 9, right? And then I could start over again, but I've got more than 6 here. So let's build and run. All right, so we can see now that we got 6 decimal places, 2, 3, 4, 5, 6, 8. It actually ended up rounding here. Floating point doesn't guarantee that it will always round. It's related to the way things are stored in memory. There are functions in C libraries that you can, if you need to have something round a certain amount of decimal places, you'll call the rounding function. You can't guarantee that your output will always round. Right. But we got the 6 decimal places. Now, how do we change that if we want to have less decimal places or more? Right. We can add to this field here precision specifier. So instead of %f, I'm going to type 0.2. So you have to have the period for the point, and then the number that follows this is the number of decimal places you want to see to the right. So let's build and run. Oh, sorry, just hit the run button. Remember, I need to rebuild because I made changes to my program. All right, so now you can see the period dot 2, right? Then now specifies that we only want 2 decimal places here. And that goes in between the % and the F, right? If I change this to 9, right, I end up getting 9 decimal places to the right. All right, so we can control the way we want to see this. If I say 0%, 0, what do we get? Right. So if I say %0, right, notice it just truncated. Doesn't show the decimal point, basically just shows us the integer value of this. So if I don't want to see anything to the right of the decimal point, I'll get that. All right, so experiment a bit with this, right? This works for both doubles and floating point types. And in our next series, we'll move on to how we work with characters.